up to this point, we've learned how to solve a quadratic equation by factoring and completing the square and using the quadratic formula. So from today on, we're going to then talk about how to solve polynomial equations. Okay, so we're going to start off and we're going to do it step by step. And so by the end of the lesson today, you should be able to simplify a polynomial expression by factoring. And you need to be able to recognize the sums and differences of cubes. And you need to be able to combine cubes and squares. So we're going to start by reviewing what we talked about when we talked about squares. Okay, when we talked about squares, there were a couple of different kinds of squares that we talked about. We talked about a square of sums, okay? And when we talked about a square of sums, okay, then we're talking about a plus b squared, which equals a squared plus 2ab plus b squared. Okay, and that's something that it will come in handy if you can go ahead and memorize that. If you don't memorize it, you can always FOIL it. Easier to memorize it. You can also take the square of a difference. Okay, you can also take the square of a difference. Okay? And when you take the square of a difference, you end up with something very similar with an a minus b squared, which is a squared minus 2ab plus b squared. Okay? And then we have my personal favorite, because when you're a math teacher, you have to have a favorite, right? And this is your difference of squares. Okay? And the difference of squares is when you have a squared minus b squared, and that comes from the product of a plus b times a minus b. So this is what we've done up to this point, because quadratic functions, right, are dealing with squares. What we're going to deal with now are functions with a greater degree than that. Remember, a degree is the highest power that a function is taken to. And so the highest power for a quadratic function is a square or a 2. We're going to go higher than that now. So I want you to be able to recognize some of these. Okay? I want you to be able to see the sum of two cubes. Okay? The sum of cubes. And so the sum of cubes looks exactly like it sounds. Okay? And it looks like this. A cubed plus b cubed. All right, and when I'm factoring this into a simpler form, I end up with this expression, a plus b times a squared minus ab plus b squared. Okay, so then this particular thing is a sum of cubes. And you're going to need this because when you get into the position that you're going to try and solve, this will come in handy because this is being reduced down. I also want you to be able to recognize the difference of cubes. Okay? The difference of cubes. All right? So if it's a cubed minus b cubed, then what I'm looking at is I'm going to decompose it. I'm going to factor it into these terms, which is a minus b times a squared plus ab plus b squared. It's really important to note here that this is not the same as that a plus b times the square. It's not, right? Because if it were, there would be, up in here, there would be a 2, okay? And that's not there. And so I don't want you to get confused that that's what it is. There is no 2 there. It is not necessarily the a plus b times the a plus b squared term. All right? So when we're using these, what I want you to be able to do is to be able to recognize them and to be able to factor them. Okay? So let's look at an example here. Okay? Let's look at an example here. So let's look at 16x to the 4th. Whoops. You know what? I don't really want to use blue. Let me switch back to black. 16x to the 4th. Okay? 16x to the 4th plus 54 xy cubed. Now, as we go through and factor, you still have to remember all of your factoring rules from before. So when I ask you to factor this, the first thing I want you to see and the first thing I want you to factor out is the 2x, right? Each of these has a 2x in common. So I'm going to factor out a 2x out of the 16x to the 4th and a 2x out of the 54x. So it's going to look like this. Please be sure to write your equal signs. Remember, the little things are important. Okay, let's factor out a 2x. It's going to look like this. 2x times, if you divide 16 by 2, you get 8. You have two exponents of 4, and then you're dividing by x, so subtract that, becomes x cubed. And then you have 54 divided by 2, which is 27. You factored out the x, so the x term has disappeared, so now you have a y cubed term. Now, we're not done yet, right? Because based on what we saw over here, which one of these terms is it, right? I am, of course, looking at this one. I have over here a sum of cubes, right? I have a sum of cubes, so let's go back to the other page. I have a sum of cubes right here, right? So I can factor that. Now, because I'm not doing anything with the 2x, I'm going to leave it alone. Okay, so I'm just going to write equals 2x. Okay, now I have this sum of cubes. Remember, really quickly, let's remind ourselves over here that the sum of cubes, whoops, undo. The sum of cubes here, it's not wanting to take my pen. The sum of cubes here, okay, the sum of cubes here, it looks like this, right? It looks like this. A plus b times a squared plus, or I'm sorry, minus ab plus b squared, right? And that's what it looks like, okay? So what I want you to do here is I want you to figure out which term is your a term and which term is your b term. So my a term, my a cubed term, okay, I'm going to use as my 8x plus 3, and I'm going to go ahead and use that red so you can distinguish it. 8x plus 3 is equal to a cubed, right? So what is my a? Well, I want to take the cube root of both sides. A equals the cube root of both sides. If I cube root both sides, I end up with 2x. So if my a term is 2x, okay, then I can write the first term here. Remember, it's a plus b, right? It's a plus b up here. So my a term is 2x. So let's figure out now what our b term is. The b term here is this 27y cubed. So I'm going to use that over here. Let's hope it fits. 27y cubed is my b term. Okay, I know that's getting a little crowded. If I take the cube root of both sides, then b equals 3y. So that's my b term. So now I can have my a plus b, right? My a plus b plus 3y. And then let's go ahead and put in the rest of the terms. A squared, so 2x squared here is 4x squared. And then minus a times b, 2x times 3y is minus 6xy. Okay, and then we're going to add b squared. B is 3y, so it'll be 9y squared. Okay, so this is the factored polynomial. Okay, this is the factored polynomial. This piece right here is your answer for that. Okay? All right, let's get a new page and do a different kind of example. What about factoring by regrouping, right? Remember at the very, very beginning, we said that we needed to be able to recognize sums and differences of cubes, so we just did that. And we also need to be able to simplify a polynomial expression by factoring. So let's do that. Let's simplify one by factoring. So let's look at this example. Okay, get my black pen back. 8ax plus 4bx plus 4cx. If you're like me, you're looking at this and you're going, hey, I see some things that are similar. And you do, and that will come in handy in just a minute. Plus 6ay plus 3by plus 3cy. Let's go through and mark what is factorable. Okay, this is my expression. So usually I like to go through and mark. You can do this as well. I want to mark the things that I'm going to factor. So I see a 4 and an x and a 4 and an x. 8 is divisible by 4, so I'm going to take that 4 and that x out also. Okay, let me switch to a different color. I'll use purple. And let's find what we have in common here. I see a y. I see a 3. Okay? So, let's look at this. Okay? Let me factor out that 4x first. If I factor out 4x, that leaves me with 2a plus b plus c. Okay? And on the other side, since these are all addition, I'm going to go ahead and factor out a 3y, right? Those little things that are underlined in purple. And that leaves me, conveniently enough, with 2a plus b plus c. Okay? So if I look at it this way, I'm going to regroup myself here. Right? I'm going to regroup this term and this term so that I can multiply them. So it's going to look like this. And then I'm going to leave the other term exactly the same. Okay? And so now I've regrouped the terms, and this is my factoring by regrouping. So let's do one more. Let me show you how to do recognizing combinations of cubes and squares. So let's do the most basic one here. X to the power of 6 minus y to the power of 6. This kind of looks like a difference of squares. It kind of looks like a difference of cubes, but it's kind of not really either, is it? Because it is to the power of 6. So, what I want you to do when you look at this is, I want you to see, okay, that it is the difference of two squares. That's how I would see it, because the difference of squares is my favorite, right? What I see here is this. I see that this is x cubed squared minus y cubed squared. Okay? And so what I'm going to end up with when I do this is I'm going to end up, what I'm going to do when I do this is I'm going to end up with this, right? X cubed squared minus y cubed squared, okay? And then I'm going to end up with my a plus b, a minus b. X cubed plus y cubed times x cubed minus y cubed. Okay? Now, of course, you can recognize these now as a combination of cubes, and we looked at that up here. Remember, we saw the sum of cubes and the difference of cubes. So I'm going to go ahead and put those in now for that term. Okay, I'm going to go ahead and put that in now for that term. So this first term becomes x plus y times x squared minus xy plus y squared. And then the second term is times x minus y times, I ran out of space, so I'm going to go down to the next line, times x squared plus xy plus y squared. Okay, so these are some of the most basic ones. Hopefully you found that helpful. When we get back together the next time, we'll deal with solving some more complicated polynomial equations.